Hi, my name is Nick Stasulis and I work with the main office of the New England Water Science Center. In this video, we will discuss situations where manual verticals are usually used and how they are done in the TRDI Section by Section Pro software. When collecting midsection data with an ADCP, whether it be in open water or under ice, you will likely run into several cases where you can't collect valid data, or a case where you need to define a feature of a cross-section. Using a manual vertical will allow you to enter information to account for both. Be clear that having an entire measurement made up of manual verticals would not be appropriate. They are meant to supplement a measurement of mostly valid ADCP data. Also, it's good practice to document why a manual vertical is needed and how depth and velocity readings were determined for a manual vertical in the field notes. Now, let's discuss some of the common situations where a manual vertical would be used. A bridge, pier, or island are both cases where using a manual vertical is useful. A manual vertical allows you to enter a location, depth, and velocity to define something in the cross-section. For the case of an island, you'd enter the location for the start and end of the island in two separate manual verticals, with a depth and velocity of 0. For a bridge pier, you'd also enter the start and end location in two separate manual verticals, but the depth would be used based on a sounding or nearby station, and the velocity would be based on the previous or next station. Notice the manual vertical dialog displays the previous vertical's velocity. Also notice that the entry here is not a coefficient, it's a velocity. Another common situation is a location where there is water, but you are unable to measure it, commonly due to the ADCP not being able to measure due to a shallow depth, or exceeding some other operating limit. In these cases, again determine a location for your manual vertical and enter a depth and velocity based on soundings, surrounding stations, or intermittent data. With under ice measurements, you'll notice there are options to enter information related to the ice conditions. Commonly with ice measurements, you'll encounter slush from the river bottom to the bottom of the ice, and since there's no water, the ADCP obviously can't make a measurement. In these cases, you could sound the total depth with a rod and enter a velocity of 0. Essentially, your entire effective depth area would be slush. Another complication during under ice measurements from slush is when slush in one area of the cross-section doesn't allow the ADCP to be used because the water between the slush and the river bottom is too shallow. In these cases, you could measure the depth and velocity with a current meter on an ice rod and enter those values into the manual vertical. Again, be sure you note that this was done in the field notes. As you can see, the option to enter a manual vertical is a great way to document odd features of a cross-section, or document a station where the ADCP cannot measure.